Why does the sun have an 11-year cycle? Can we send a probe to Oumuamua? How did I get interested in space? All this and more in this week's Overtime Question Show. Hey everyone, I hope you're enjoying your summer. I know I am. So this is the next episode of the Overtime Question Show. Of course, these are the extra questions that you didn't see in our weekly question show that we publish. That's because we do the live stream every Monday and it's 2 hours long. The first hour is the part that we edit down, make it to the question show. The second hour, we call that overtime. And then we just go for another hour and just answer more questions. So there's like 40 hours for the last year of overtime questions. And so we're releasing some of the best. So enjoy the Overtime Question Show. Kim Barron, do we know why the sun has an 11-year cycle and not some other period? Is it related to its size or age? We don't know why the sun has an 11-year cycle. This is one of the questions that spacecraft like the Solar Orbiter, like the Parker Solar Probe, are trying to figure out. What we do know is that it has something to do with the differential rotation of the sun. You know, the different parts of the sun are rotating at different speeds. And we've also learned very recently that in fact, the magnetic fields of the sun are not emanating from a dynamo deep down inside the sun, but they're actually relatively close to the surface. So there's a region that is, you know, a few thousand kilometers below the surface of the sun where the magnetism is emanating from. And this is actually a fairly new research. So why does it follow this 11-year period? We don't know, but it is like clockwork. It's kind of amazing. You know, you've got the sun, you've got the North Pole, you've got the South Pole, and then over time, the magnetic field lines all get jumbled up, and over the course of 11 years, it just flips. And now the North Pole and the South Pole are flipped. So yeah, we don't know. And you get solar maximum and then solar minimum, and then solar minimum and then solar maximum, and then solar minimum, solar maximum, and then it's completely flipped. So to go, like, it takes 22 years for the full cycle of the sun, 11 years to get the flip, half of that to go from solar minimum to solar maximum. Michael Purcell, do all stars have their own solar cycle? We don't know. You know, we see flares coming from other stars. And so we've got to assume that they have sunspots and they have magnetic reconnections that's causing this, but we don't really know what is the solar cycle. I don't know of any papers offhand, but I've got to assume that other stars have solar magnetic activity that rises and falls over a cycle. And I just don't have the numbers in front of me. But I've got to assume people have just like measured the flares coming from a star over long periods of time and noticed that there's a cycle that goes on. I mean, we definitely see variable stars, but that's changes in the luminosity of the star. Jack Trading, why did NASA never send a probe to Oumuamua? Well, like when astronomers had discovered Oumuamua, it was already on its way leaving the solar system. So it was beyond its closest point. There was no time to prepare a spacecraft to do a flyby. Now, there are a series of papers that come out that say, well, if you wanted to do a flyby of Oumuamua, you still could. You just have to take a Falcon Heavy, put a tiny little spacecraft on top of it, do an Oberth maneuver around the sun, and you should be able to catch up with Oumuamua. So it is still possible, but it's just priorities. Like, it would cost billions of dollars, and especially you'd still have to rush the mission. You wouldn't get that science data back from Oumuamua for probably 30 years because you have to catch up with this object is moving at, you know, interstellar velocities. So it's a tricky job to be able to catch Oumuamua. It is still possible, but sort of right at the very limits of what is possible right now. Leviathan, what got you into space stuff in the first place? So I don't really know. Like my earliest memories about space, I have a bunch. So I'll try and kind of put them in, I don't know if I can put them in any kind of order. So I remember seeing a meteor shower with my parents, and I must have been 4 or so, and I just thought it was the coolest thing. And then I think I was 5, and my parents bought me the Time Life books, Our Universe. And I just was obsessed by that book, and I just read it cover to cover, page after page after page. The only part was there's an image of it I can remember very vividly. There's an image of an apple, like a dried up apple. And I think they were trying to get across how Mercury or the moon are like shrinking and they're drying up. And the picture disturbed me. And so my mom taped over a piece of paper on that one image of an apple so that I didn't have to look at it, and then I could just look at the book. And I would read it like every day, all day, every day. That was my favorite book. I did also like the book about getting treasure from the bottom of the ocean. There was like another Time Life book about deep sea treasure hunting. And I always laugh about this, that, you know, in an alternate universe, that's my other career, is that I'm a deep sea treasure hunter, because that was the other book. And I was into dinosaurs too, but I was mostly into space. And then I watched Star Trek, you know, sort of at the right age. You know, Star Trek had come out, I don't know, 10 years before. Well, it had only come out a couple of years before I was born. My parents watched it, loved it. And then when the reruns showed up on TV, we would watch it together. And then I watched Doctor Who. And I really got into science fiction and space. I watched Star Wars, 1977, 78. And it just blew my mind. Like, what an amazing show. My dad had watched the moon landings, and he sort of organized our house around watching the first launch of the space shuttle in 1981. And then I was 10. So that was pretty meaningful. And in fact, back in 2011, I took my father, who I mentioned earlier in this episode is a professional photographer. I took him to Florida to be my photographer for the second to last launch of the space shuttle. And so we went and I reported on it, and he took pictures, and unfortunately the launch was delayed. And so we didn't get a chance to actually watch the space shuttle take off, but it was great to go to the Kennedy Space Center and tour around and see the whole thing. He had a great time. And then I think I was like 14 and I 13, and someone had a garage sale, and they had a bunch of astronomy magazines and sky and telescope magazines, like stacks and stacks of them. And so I got them at the garage sale for free, I think. And so I just would look through these magazines and see all these amazing pictures of space. And then I would start to learn. I sort of through osmosis learned the different kinds of telescopes and how they worked and what the different capabilities were. And then eventually I bought my own telescope. I think I was 14 years old, and I bought this telescope out of Vancouver. It was a 4-inch Newtonian reflector on an alt-azimuth mount. It wasn't great, but it let me see the rings of Saturn, the moons of Jupiter. I could see Mars, the ice caps, craters on the moon. And my parents would have like people coming over for dinner, parties, things like that. And I would set up this telescope, and then I would just have a lineup of the people at the party coming out and looking through the telescope. I was sort of doing sidewalk astronomy. And then when I was in high school, I joined the journalism program at my high school, and I reported on space and astronomy. So I, like, every month I would write about what constellations were up in the sky, or comets, or things you could see, meteor showers, solar eclipses, things like that. And it's kind of crazy that I then, for some reason, just like dropped it all, and it took me about 10 years to come back to, oh, actually, I really like space and like to communicate this thing. Logic bug, is your real name Cain Fraser? No, my real name is Fraser Cain. Yes, it is the same name as a famous character on Cheers, although slightly different. He's Fraser Crane. But I had the name first. When you think about it, when did Cheers come out? 1981, and I was born in 1971. So I had the name for 10 years until some idiot thought up the name of a character, and then they made a television show, and like, I've been waiting for the show to be forgotten, and then they made a remake, but the remake bombed, and so I think I'm all right. Steve Martini, would you rather have a Venus mission or a Jovian moon mission? They're all well supported at this point. I mean, there's probably 5 spacecraft on their way to Venus, and we've got Europa Clipper and the JUICE mission going to Europa and Jupiter's moons. So I think that's well covered. So I would rather have like a mission to Enceladus. Bucko, how do you rank China for sharing info, like a comparison to the Soviets during their time? So there's like 2 different things to distinguish between. One is researchers who come from China, and they are contributing their papers onto various journals like Journal Nature and Journal Science, and they're contributing a lot of papers to the prepresses. Like, I see a ton of papers which are made by a collection of researchers from China on arXiv. And then they also produce a lot of press releases. So you see press releases from the Chinese Science Administration, you see from Beijing University, Shanghai University, you see these press releases. So that comes out a lot. And then they give access to their telescopes and some of their science data. So, but it goes through an internal process. Like with NASA, they just dump their pictures out onto the internet. As fast as they take them, you can just go, you can see pictures were taken by Curiosity yesterday on the internet. And you do not get that from Chinese missions. But that said, they've been pretty good about sharing their information, sharing their raw data. We get a lot of science results coming from, say, the Chang'e missions, from the Tianwen mission. And we know a surprising amount about what their future plans are. Like, we know the blueprint of what China is planning to do with sending humans to the moon pretty clearly. We know all of the large hardware. We know the capsules. We know the landers. We know which missions are going to go before, and even sort of what's going to happen after they've completed their first landings on the moon. But you can tell that everything has had somebody from the government look through this stuff before it's released to the public. And so, I wasn't really reporting during the Soviet era. So I don't really know what it was like to try to be a science reporter during Soviet launches. When Yuri Gagarin flew to space, I don't know what it was like trying to get information out of the Soviets about that. I've reached out many times to do interviews with Chinese researchers, and it hasn't gone well. I've reached out to like the architects of the human moon missions. I've tried to reach out to the principal investigator of their version of the Hubble Space Telescope, and nobody has answered my queries. So, but who knows? I mean, maybe it's a cultural thing, maybe it's a language thing. I don't know. So, they're not great. They're not great, I would say. They don't just put it all out there. They don't make it easy to find, but they are better than they could be. So we're able to do some reporting, but not as much as I would like to be able to. When people don't share information on the internet, my default is to go, well, then I don't care, right? Like, unless it's really going to affect us, if your instinct is to hide what you're doing, then I'm not going to get that excited about it, which is too bad for them, I think, right? That they would do well with us in the West being excited and enthusiastic. Think about K-pop, right? Or think about anime. Like, as you release your culture to the rest of the world, as you show your authentic self to other nations, then the things that you're very good at will catch hold and people will be excited about it. But if you're constantly going to filter it and edit it and second guess your authentic nature to the rest of the world, then people are going to sense that and they're not going to be that into it. And so I'm not that into it, which is too bad, because they just landed a sample return mission on the moon. But I can't get the raw data from the landing. I can't take it, see all the pictures that are being sent back by the mission. I just get what's released out onto the web through the government, which is, suboptimal. Busy Billy B33, do Chinese scientists get time on US ESA observatories like the big ground ones or JWST and Hubble? Yeah, absolutely. So there are no limits to who gets to work on various telescopes. And so Chinese astronomers get time on Hubble Space Telescope and James Webb all the time. As long as you make a good science case, you get to work on the telescope. And European and American astronomers get access on, like, say, the FAST telescope all the time as well. So there's a ton of collaborations. There's a recent mission, the Lobster Eye telescope, that was launched, and it was a collaboration between the European Space Agency and the Chinese Space Agency. And that's my preference, is that there's these collaborations. They work together. Luke Skydropper, do you play video games? Do I ever? I play video games too much, I think. What am I playing right now? Well, I was playing a whole lot of Project Zomboid. So I have about 1,000 hours in Project Zomboid, which is a problem. And my last character, he just died. And I almost threw my Steam Deck down for good. I play mostly on the Steam Deck. I don't really play any PC gaming anymore, just because I I spend a lot of time in front of this computer as I don't want to spend 1 second more, but I really love the Steam Deck. So if you're looking for a way, if you're like a gamer that hasn't gamed in a while and you're feeling kind of, oh, I don't want to play my games, like Steam Deck is the way, because it has access to your entire Steam library, and it's great. And what am I playing right now? I'm playing Deep Rock Galactic right now. I play a ton. I've got well over 1,000 hours of RimWorld. The kinds of games that I like are strategy games. So XCOM, Europa Universalis, stuff like that. But I also like action games, Subnautica. I really have a soft spot for like space simulator type games. I really like that kind of thing. Yeah, I've played so many video games. Yeah. And what's cool is my kids are into games, right? Like I was able to get good gaming platforms, and I was able to make sure that they were playing good games as kids and watch good media as well. So, and still, you know, when my son and I go for walks, when we hang out, we talk about the games we're playing and like deeper philosophical issues about game balance and, you know, like why play Rocket League when you're just a car that's shooting a ball? And like, what is the end game of Elden Ring? Like, what are you really learning how to do? So anyway, yeah, I play a ton of games. Ton of games. Too many games. The thing that I got recently was I got a Quest 3. So I'm now playing VR games, and they're cool. I mean, there's something really magical about being in virtual reality, but the ecosystem of games is still not great. You know, there's a new Half-Life game that's pretty great, but the games themselves just aren't the level of maturity that traditional PC games are. So, but still, I think it's crossed the chasm. Like if you've been hanging back and going, oh, video games are like virtual reality games are it's like too complicated and it's too expensive, I don't want to do it. I would say the Quest 3 is amazing, and the Quest 2 is affordable and still pretty good and self-contained. Now, the thing I don't like about the Quest 3 is that it doesn't, like, you can't connect it to your Steam library unless you have to run a virtual desktop on Steam that then connects to your Steam library, and you run it on your computer, and you can play your Steam games on your Quest 3, but it's not a great experience. There's lag and there's all kinds of issues. And so you kind of want to veer towards buying the games on the Quest platform, but then you're locked into another platform, and this one's Mark Zuckerberg's platform. So I know, investing in games that aren't in my Steam library. So, but I do, yeah. So anyway, if you're VR curious, I recommend the Quest 3. And if you're VR curious and you don't have a lot of money, I recommend the Quest 2. It's pretty good. PTCP. What does a neutron star look like up close to the human eye? What color are they? So they're white and sort of slightly violet. So temperature-wise, they're going to match blue stars, but they're tiny, right? So if you got close and looked at a neutron star, it would just look like this bright, glowing, bluish white star. And if you could look at it with filters and more filters and more filters, it would just look like this smooth object rotating very quickly. The bogs of Mordor. Could a fully refueled Starship send a payload to the outer solar system faster? Sure, yeah. Like right now, things like, say, New Horizons, the Voyagers, they were limited by the launch rocket. And so you have a rocket, it launches off Earth, it uses up its various stages, it has a upper stage that is able to kick the spacecraft into the fastest possible orbit that it can. The spacecraft does flybys of, say, Jupiter and Saturn and gets, gravitational assist. It's going faster. But if you could have Starship and you could launch into orbit and they could fully refuel, and then it could fire its engines and accelerate and have all of that fuel, yeah, you could go very, very fast compared to existing rockets. Armando Miranda, do black holes attract other black holes? And if so, does it matter how big they are? So, like, black holes are not vacuum cleaners. And so there isn't anything special that a black hole is doing in terms of gravity compared to any other object that is made of mass. And so for a good example, like if you took the sun and you just replaced it with a black hole that had the exact same mass as the sun, then all of the planets in the solar system would just continue to orbit around the black hole sun just as they did before. So nothing new or special would happen just because you would turn the sun into a black hole. And so then out there in the universe, all the times you got interactions with black holes, it's exactly as if you had a star that was in that exact location that had, say a star that was 8 times the mass of the sun or 10 times the mass of the sun, and it's orbiting around another star. Well, you could just replace it with a black hole. It's exactly the same. And especially black holes don't specifically attract one another. Now, the rules do change when you get close enough to a black hole. When you get to a point where the tidal forces start to tear a star apart or a planet apart, then instead of it being a discrete sphere that is orbiting around something else, it's this smeary mass that is falling into the accretion disk and it's passing through the event horizon. And, the rules kind of change when you get really close to a black hole. But as long as you're sufficiently far away from a black hole, it's as if any other mass out there in the universe. Church discography, how close have you been to a moose? So there's a Canadian question if I've ever heard one. I have never seen a moose. But we don't have moose on Vancouver Island. So I've never seen one. Have I ever seen one? I might have seen one on a road trip in the interior of British Columbia. But I don't think so. No, I don't think I've ever seen a moose. We have this area of the forest that I've sort of thinned out and cleared out. It's really pretty. Like you can see right through the trees, all the underbrush, and my wife will be sort of staring out the window. I'm like, what are you looking at? She's like, I'm looking for my moose. Even though she knows we don't have a moose on the island. She's just like hoping at one point, if she just watches long enough, a moose will pass into the field of view. I don't think you want to be close to a moose. They're pretty terrifying. Coach Gurnison, is AI progressing too fast? Yes. In my opinion, I think we need to slow down. I think I didn't sign the slow down the AI progression, but I do think that it's time to slow down. That right now, the current models, they're nothing to be afraid of. GPT-4, GPT even 5, I'm sure will be fine. But there is the potential for these things to cause harm, both at the small level, when they fall into the hands of people who mean to do mayhem. And there are open source, open weight things you can download. You can download the new version Llama 3 from Meta. You can download their 70 billion parameter version. You can run it on a pretty beefy computer, and you can generate custom emails for people that you're attempting to target and to convince them to give you their money at scale. So we are already at a place where now bad actors can take artificial intelligence and they can do bad things with it. But there is also things that people can do that is good. I mean, I use artificial intelligence all the time, mostly to design recipes for me, what we call Chef GPT. But how could we expect to make something smarter than us? The question is, can we make something that is smarter than us? Is the human brain the smartest possible thing that could possibly exist? Of course not, right? It's jelly that evolved over billions of years. And so it is not the most efficient thing. And, it uses 12 watts of energy. It's very efficient, but it's not what could be the most efficient thing. If you use the same amount of mass, the same amount of energy, I'm sure eventually someone will engineer something that is better, that is smarter. And, we're not as smart as can be. And how could we expect, if we make something smarter, that things are going to turn out well for us? Like, imagine the chimpanzees going, doing their science experiments and coming with human beings and like, this will be fine, right? Like, what's the worst that they could do? Well, the worst they could do is take over the entire planet and destroy your habitat, and sometimes eat you. That's the worst that humanity can do to chimpanzees. So I think that already the kinds of artificial intelligence that has been developed we could be digesting the value from those large language models for decades, that all of the hallucinations that they go through, I don't think the solution is to just go and spend 10 times as much money, burn the energy of a small country, and see if brute force will get you the answers that you want. I think the solution is that we work with the technology that we have to understand how it functions, what the risks are, develop proper mitigation strategies at all levels, and properly digest this before we just run headlong into this arms race. And it is a race. It's a race, right? It's an arms race. But the difference between this and nuclear weapons is that artificial intelligence, the way it's been described, if you're listening to like Eliezer Yudkowsky, it's like a machine that spits out gold until it sets the atmosphere on fire, right? And so you've got OpenAI and you've got all these different companies, Google, and they're just running headlong into this future because it's a race. And if they don't do it, then the competitors will do it. So yeah, I think that we are absolutely moving too fast on AI when we don't know how it works, and we don't know how to control it and to manage it. And we don't even know what we want. Like, how do we align artificial intelligence when you could ask two different people what they would like artificial intelligence to do and they're going to disagree? Like, imagine if everybody on Earth, every single human being on Earth had access to a genie with 3 wishes. Like, how would that work out for us, right? It would be bad that we would have overlapping wishes. And really the winner would be the person who stayed alive the longest and was able to ask their final wish. I'd like you to undo all the other wishes and make the world the way I want it to be. So, yeah. So I think I do not have a lot of confidence. My P-doom is relatively high. Logic bug. Do you have or use a space specialized ChatGPT to find information? No, I just use the regular ChatGPT and approach it with caution and skepticism on any answer that it gives me, right? So what do I use ChatGPT for? So I will feed it a paper, and I also use Google Gemini. Like, the 1.5 version of Gemini is pretty good at this. So I will feed it a paper that I want to understand better, and because they're very technical, and I'm not a scientist, so I'm trying to understand the paper, and then I will then start to talk to the paper through the ChatGPT. So, like, what is this paper trying to say? What are the implications of this? And then I will sort of describe my understanding, and then ChatGPT will say, yeah, that's right, or here's where you got a little bit wrong, or whatever. And then I use that as a sort of a starting point to begin a deeper investigation into the paper. Like, I'm trying to figure out, like, is this worth my time? And that's what I find very, very useful. Now I'm going to thank a couple of people on my team, but first I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Barry Lake Roofing, Bill, David Giltonen, David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Spiderswap.io, Paul Robock, Stephen Krasaki, Stephen Fowler-Munley, and Vlad Chiplin, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So this week, I would just like to give a big shout out to 2 people on the team who really make these videos possible. And so the first is Chad Weber, who is the editor for this video. He's the editor for the Q&As, but he also does a lot of the back-end technical programming on our website, on the our content management system, and he's edited hundreds, I don't know, Chad, 400 of our videos. Pretty amazing. And then the other person is Anton Postnikov, who is my producer. He helps and does the editing on the Space Bites, as well as all of the interviews that I do. And again, has probably done 400 or 500 videos on this channel, and does all the post-production on both the videos, the Space Bites, as well as all of the QAs. And so the 2 of them are amazing. And so thank you, Chad and Anton. Maybe next week I'll thank all the writers on Universe Today. But all right, we'll see you next week.